this session, we will discuss about the Moore machine. Here, Moore machine that consists of the 6 tuple, same like a Mealy machine, but the transitional function is different for the Moore machine as well as the Mealy machine. Last session, we have discussed about the Mealy machine. Here, we came up with the Moore machine with the transitional representation and how we will go with the transitional diagram of the Moore machine. The Moore machine that contains the 6 tuple. This is also one type of the finite automata with output. Here the Moore machine that depends only on the present state itself. But when you see the Mealy machine, the transition function that depends on the present state as well as the present input. Here we will see the Moore machine. So here we have 6 tuples Q, that is finite non-empty set of states. Sigma, that is the input alphabet, set of input alphabets. So delta is the transition function, so that is mapping from Q into summation to Q, and we have the set of output alphabets, and lambda we have the output function mapping, that is Q to, that we have coming to the Q derives delta, because here delta is the output alphabet that depends only on the state itself. So whenever we have Q naught, that is the initial state. Already we have discussed about this Moore machine with 6 tuples. So here we will see the transitional table. This is the example transition table we have taken. So present states we have A, B, C. Input alphabets we have 0 and 1. So here we have taken present state to the next states on input 0 and input 1, and we have the output. So based on this transition table, we will see how to draw the Moore machine. Here the states we have A, B, C. Whenever we have the present state A, the output is 0. Whereas in the Moore machine, here the machine depends on the present state itself. So here we are writing the output alphabet on behalf of the and behind the present state. Same, we have the state B. So given output for B is 0. We are writing on behind B because here the Moore machine, it depends only on the present state. C, the output is 1. We are writing 1 with the state itself. Now we have to represent the next states on input 0 as well as on input 1. On present state A, input alphabet 0, the next state is A itself. So we are giving the self state. On input 1, the next state is B. Coming to the present state B, on input 0, wait for a while, on input 1, the next state is B. From present state B, input 0, the next state is A. On input 0, the next state is A. On input 1, the next state is C. On input 1, the next state is C. Coming to the C, the present state C, on input 0, the next state is A. On input 1, the next state is C. So we will write the self transition. Like that we will draw the Moore machine diagram. So with the present state. So it depends only on the present state. Whenever we have seen the Mealy machine, that depends on the present state as well as the present input. So we have taken the output symbol with the present input on the Mealy machine. This is the Moore machine. We are taking the output symbol on the present state. So finally we have to remember that the Moore machine that depends on the present state, and also it is a finite automata with output. Finite automata with output. Now we will see the one more example. How to construct the Moore machines. First, suppose construct a Moore machine. I am taking the example. Construct a Moore machine. So if substring 001, the output is A. For suppose substring 110, the output is B. Otherwise C. So if we have the question like this, so based on these conditions, we have to draw our Moore machine. So Moore machine, we all know that. So we have the states like Q0, Q1, Q2. So because we have 001 as the substring, 001, the length of the string is 3 plus 1, we have to take the 4 states. So we will write 001. So because the substring is 001, 001. According to the condition, if substring 001, the output is A, right? So A we have to write with the state because it is a Moore machine. Remaining all the cases, otherwise output is C. So we will write it as the C here. So next, coming to one more condition, whenever we have the substring 110, the output is B. So 110 means we will represent 1, 1, 0. So whenever we are reading the input from the initial state 110, the output is B. Output we have to represent with the state itself in the Moore machine. So we will write B here. Remaining all the cases, the output is C. So remaining for all the states, we have to make the output as C. Like that we have to draw the Moore machine. So 001, the output is A. So we are writing the output symbol along with the present state. So remaining in all the states we have the, otherwise output is C, right? So remaining all the cases we will write the C. Next we have the one more condition, that is 110, the output is B. Remaining all the cases, the output is C. Like that we have to construct the Moore machine. For same this we have constructed the Mealy machine. So like here we will mention the output with the along with the input symbols. So here it is a Moore machine. We have represented our output symbols with the state itself. This is about the Moore machine. So up to now we have discussed Mealy machine and the Moore machine. The both are classified according to the finite automata with outputs.